All right, ladies and gentlemen, welcome to today's little worked examples from the Practice Solving Quadratics 2 review. We're going to be reviewing how to solve quadratics. There's three methods. There's solving by factoring, solving by completing square, and solving by the quadratic formula. We're going to start by factoring. The idea of factoring is going to turn this into two binomials where it's like x plus or minus something, and then x plus or minus something, and it's going to equal 0. And the benefit of that is if you have two factors that their product is 0, then that means one of those factors has to be 0. And so you're going to figure out the factors of 20 that add up to be 9, and those numbers happen to be 5 and 4. And so 5 times 4 is 20, and 5 plus 4 is 9. And so now we have our two factors. And if you have two numbers multiplying together to equal 0, that means either the first one has to equal 0 or the B one has to equal 0, one of the two. And so we can set up two different equations. X plus 5 can equal 0, or x plus 4 can equal 0. And then you can solve both those equations fairly quickly by subtracting the number over. And that leaves us with x can be negative 5, or x can equal negative 4. And those are two possible answers. When you're solving quadratics, there's always there's always two answers, and sometimes the answer is the same answer, but there are two roots or zeros of each quadratic. I wanted to show you number 7 because this one does not factor nicely here. And the way to solve this one is you're actually going to take the leading coefficient and then the constant term and times them together. You're going to get negative 84. You have to find factors of negative 84 that add up to be 17. And so, you can try things like negative 2, which will give you 42, or you can try negative 4 and see what that gives you, which comes out to be 21. It's also divisible by 6 and 14. It's divisible by negative 12 and 7. And you have to find out which of these factors are going to add up to be 17, and it happens to be these two. And so we're going to write our two binomials. You're going to use, you're still going to use 6a in the front of both temporarily. So you're looking at this, and it's going to equal 0. But these are too big, and that's because if you do 6a times 6a, you're going to get 36a squared, which is too big. And so we actually need to get rid of a factor of 6 in these two binomials here. But if we attempt to divide by 6, neither of these go evenly. And so this is an extra tricky one because it's not divisible by 6 on either of those. And so we're going to take the factors of 6, which are 2 and 3, and attempt to divide by 2 and 3. And on this one, it works, and on this one, it works. We could have tried this way, but those don't really work. And so we're going to try 2 and 3 like this. These do go evenly, and if we successfully divide by 2 and 3, would have successfully divided by 6, reducing our binomials down small enough. And so it's going to give us 3a minus 2 times by 2a plus 7, going to equal 0. And so now we've successfully factored this. You may want to test this out and distribute your 3a, your negative 2, and see if you get what you started with, kind of double checking. But each of these factors can equal 0. So you got 3a minus 2 equals 0. You just do a quick add 2, you got 3a equals 2, you can divide by 3, and you got a can equal 2/3. One possible answer. And then the other possible answer comes from solving 2a plus 7 equals 0, which you subtract 7, you divide by 2 to get a all by itself, and then you got a can equal negative 7 halves. And so those are our two possible answers, the two roots or two zeros of our quadratic up here. So that's solving by factoring. Let's move on to another method, which is completing the square. To complete the square, you want the left side to have just the x terms, and then the right side to have the constant term. So we're going to add 87. And now we got 6x squared plus 12x. And I'm going to leave a space on purpose. It's going to equal 90. We also need this to have a leading coefficient of 1 for completing the square to work. So we're going to divide by 6, and then we got x squared plus 12x equals 15. So now we have this, we can quote-unquote complete the square of the left side by taking our b term, which should not be 12, it should be 2. My bad. Give me a second. Let me fix that. It should be 2. Yeah, we're going to take our b term here and divide by 2 and square it, and that's going to be added here. So we're going to 2 divided by 2 is 1, squared is 1. So we're going to add 1. You also have to do it over here. So we're going to add 1 over here. And that's going to give us x squared plus 2x plus 1 is going to equal 16. Well, this is a perfect square. It's the perfect square of x plus 1. If you do x plus 1, the binomial squared, you will get this. So these are equivalent. And now we're at this point, we can complete the square by square rooting. And we get x plus 1 equals plus or minus 4. And then we're going to subtract 1 on both sides. And we're looking at x is 4 minus 1. And x is negative 4 minus 1, which will give you x equals 3 or x equals negative 5. And voila, we have solved our quadratic. But let's do another completing square so you can see the process. Let's jump over to number 5. Again, we want this to we want the x terms all by themselves on the left side, so we're going to add 62 to the other side. And we got x squared plus 6x is going to equal 69. And then we are going to complete the square on the left side by taking our b term and dividing by 2, and then square it. And that's going to go up here. And we also have to add it over here. 6 divided by 2 is 3, squared is 9. So we're going to add 9. Then we're going to add 9 over here. And that's going to give us x squared plus 6x plus 9 equals 78. And we need to turn this into the perfect square that it is, which is x plus 3 squared. If you're wondering where I'm getting this so quickly, it's this number here. Right, 6 divided by 2 is 3. And so my perfect squared binomial is going to be the x plus 3 squared. There. And then the right side is still 78. From here, we can square root, and that'll give us x plus 3 equals square root of 78, which is not, it doesn't go evenly right now. So we're going to leave it like that. From here, you can subtract 3, and that's going to give us our two answers is negative 3 plus or minus the square root of 78. Yeah, again, square root of 78 is not a nice thing. It's an irrational number, so we're just going to leave it. This is the exact answer, and it's the 2, because we have plus or minus square root of 78. Let's move on to our last method, which is the quadratic formula. In case you have forgotten your quadratic formula, here it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And all those a, b's, and c's come from if your quadratic equals 0. A goes with x squared, b goes with a goes with x squared, b goes with x, and then c is a constant term, and it has to equal 0, otherwise your numbers are off. And so, if we're going to use quadratic formula on this, we need it to equal 0. So we're going to add some 12. Add some 12. And now we're looking at 3x squared plus 11x minus 14 equals 0. And from here, you're going to take these numbers and plug them into our formula. We got a is 3. We got b is 11, and then c is negative 14. Make sure you put the correct signs on these things. And so I'm going to plug into my quadratic formula. X equals negative b, so it's going to be negative 11, plus or minus the square root of 11 squared, minus 4 times 3 times negative 14, all over 2 times a, and a is 3. So we're going to go through the process of simplifying. I do recommend simplifying the inside of the square root as a step there, just so you can see what's going on there. It'll give you, that way you'll have your exact answer. And on the bottom here we got 6. And so I'm going to plug that in my calculator. You should take a moment to plug in your calculator too, figure out what goes inside the square root. All right, I got 289. That's a bad looking 9. And so this is the exact answer. You should test and see if this comes out to be integer, which would be very convenient here. Let's see, square root of 289. Hey, that does come out to be a nice integer. That comes out to be 17. And so x is negative 11 plus or minus 17 over 6. And that generates your two answers, right? You got negative 11 plus 17 over 6. And then you got negative 11 minus 17 over 6. And then you simplify both those fractions there. It's looking like 1. And then... Oh, that one's not an integer answer. Hold on. Top gives you negative 28. And that goes over 6. And that fraction reduces a little bit. You can divide top and bottom by 2. So you got negative 14 thirds and 1 are the two solutions to this equation up here. We're going to do one more quadratic formula. You should try it out yourself. Go to number 21 and plug it into your x equals negative b plus or minus the square root of b squared minus 4ac all over 2a and see how it goes. So go ahead and pause it, see if you can figure it out. Alright, let's have you check and see how you did. I failed to mention at the beginning that you wanted to equal 1, but hopefully you caught that. Sorry, you wanted to equal 0. Hopefully you caught that. So you want to add 5 over so it equals 0. It has to equal 0 for this to work. And so you plug your numbers in. B is 3, A is... Sorry. 6 is A, 3 is B, and negative 5 is C. So you plug all those in, and you're looking at your bunch of mess here. But if you do some simplifying, 2 times 6 is 12. 3 squared minus 4 times 6 times negative 5 comes out to be 129. This does not come out to be an integer or a nice fraction there, and so we're going to leave it like this, though you can generate your two different answers by plugging the numbers in your calculator and get them out. But there you go, solving by quadratic formula and completing square and factoring 3 different methods.